So, hello student. In the series of revision classes, today our topic is projectile motion. Firstly, I will discuss about the projectile motion. What is projectile motion? What are its maximum height, time of flight, range? Then I taught you some important question which have come in your previous year. After that, I will start new chapter that was your friction. And same in the friction part. Firstly, I will tell you about the friction. After that, I will discuss some important question of the friction. Okay. So first topic is your projectile. So question is that what is a projectile? So projectile, anybody which once thrown with some initial velocity near the surface of Earth and it moves along a path, curved path under the influence of gravity that is known as projectile. Okay. The trajectory of projectile is parabola. Okay. Now anybody which once thrown with some initial velocity with some initial velocity near the earth surface near the earth surface and it moves along a curved path under the influence of gravity alone, under the influence of gravity alone. Okay, the path followed by a projectile is called its trajectory, and the trajectory of a projectile is always hyperbola. The path followed by a projectile the path followed by a projectile is called its trajectory. Okay, the path followed by a projectile is called its trajectory. That went from A to B. So that was its trajectory. This is a case uh, when the projectile is thrown with a some angle at angle theta. Okay, now come to the next part, principle of physical dependence of motion. Because it is a motion under gravity, so it have two principles. So principle of physical independence of motion. Of physical independence of a motion. Independence of motions. So in the absence of air resistance, in the absence of air resistance, good morning. Air resistance, the motion of the projectile, the motion of the projectile is considered as combination of two independent motion of two independent motion. So what are the two independent motion? Firstly, I will tell you, then I will write. Okay. So suppose this was your y-axis and this is x-axis. This was y-axis, this is x-axis. If a projectile is thrown with some initial velocity u at an angle theta, so it will describe this path. Now it have two independent motion. That was the motion of a particle in x direction, and that was the motion of a particle in y direction. Okay, ux with a horizontal velocity and uy will be the vertical velocity. So these are the two independent motion on which we describe the projectile motion. First was is motion along a horizontal direction with uniform velocity, with uniform velocity. And second one is motion along vertical direction, motion along vertical direction under gravity, under gravity. That means with uniform acceleration g, with uniform acceleration z. Okay, understand? Kungala Nikita, good morning sir, good morning, good morning. Now consider the motion. That was your projectile motion. So this is y-axis, this is x-axis. Now see, suppose that was your projectile, which was fired with the initial velocity u at an angle theta. Okay, so this velocity is your horizontal velocity, which is ux, and this is your vertical velocity, which is uy. This ux is constant throughout the motion. Okay, ux is constant throughout the motion, and the value of ux is u cos theta. I have told you in a resolution of a vector that a side which is with angle theta is cos theta, and the side which is not within angle theta is sin theta. So ux is equal to u cos theta and uy is equal to u sin theta. U cos theta is always constant throughout the motion, and it is variable. Why it is variable? Because u sin theta, that means the vertical velocity, it work on the force of attraction due to acceleration due to gravity. Okay, because it works on the force of attraction due to gravity. Okay, force of acceleration due to gravity, acceleration due to gravity, acceleration due to gravity. Now see here, the acceleration due to gravity always acts towards downward. So it's always acts toward downward. 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 So uy firstly decreases from this point A to the highest point. Suppose this is the your highest point B. So A to B, it is initially decreases A to B, it initially decreases. Then at highest point, it became 0. At highest point, Uy became 0 and then increases. So that's why it is variable. Okay. So vertical component of projectile motion, that means u cos theta first initially decreases, then at highest point it becomes 0, and after that it will increases from A to B. It is decreases at B. Suppose this at B is the highest point of a projectile, so the velocity will become 0. Initial horizontal sorry, horizontal vertical velocity became 0 at point B, and from B to C it increases. Now u cos theta is throughout the motion is constant, so the acceleration in this direction will be 0, and u sin theta is always work on the acceleration due to gravity, on the force of acceleration due to gravity. So the acceleration is always there minus g. Okay. Now come to the first topic, that was your trajectory of projectile. So first topic is here trajectory of projectile. Trajectory of a projectile. So what is a trajectory? Trajectory means path. So we have to determine the equation of a path. So suppose a body reached at point P x comma y after time t. After time t. Suppose that was a point. That point is known as point P, which have coordinate x comma y at time t. Okay. So horizontal distance covered by the body, covered by the body in time t is, so we know that speed is equal to distance upon time. So distance is equal to speed into time. So distance is equal to speed into time. Speed into time. And in the horizontal distance is x, speed is ux, and suppose time is t. And ux we know that in the horizontal direction, which is equal to u cos theta into t. So x is equal to u cos theta into t. Now the t is equal to x upon u cos theta will be the time. Now vertical distance covered by body, vertical distance covered by body in time t. So for vertical distance, we have acceleration 2. So we will consider a second equation of motion, s is equal to ut plus half at square. So horizontal distance is s, u is u sin theta into t plus half, acceleration is minus g into t square. And what is t? So t is x upon u cos theta. So u sin theta into x upon u cos theta minus half g x upon u cos theta whole square. So u will cancel by u. So sin theta upon cos theta is tan theta. So tan theta x tan theta minus g x square upon 2u square cos square theta will be the trajectory of the projectile. Okay. So u, if tan theta became 0, so u is directly proportional to x square, and u is directly proportional to x square is the equation of parabola. So the trajectory of a projectile motion is always a parabola. Now next is your time of flight. It is denoted by t. So what is the time of flight? It is the total time. It is the total time for which the object is in flight. Okay. So from A to C, the object is in flight. So the time from A to C is known as the time of flight. But how we can calculate the time of flight? So firstly, we will calculate the time from A to B. Then we will multiply with 2 because it will require same time from A to B, then B to C. So at point B, the so motion considered in y direction, motion considered in y direction, in y direction. So from A to B, from A to B, from A to B, we have initial velocity u sine theta, and at highest point we know that the final velocity will become 0 and acceleration due to gravity will be minus g. So apply the formula, equation of motion v is equal to u plus at. V is 0, u is u sine theta minus gt. So minus u sine theta minus gt. So t will became u sine theta by g. So the time required by the body to travel from A to B is u sine theta by g. Okay. So total time required by a body to travel from A to C is t is equal to 2t. That means 2u sine theta by g. Okay. Next is your maximum height. Maximum height. So maximum height is at point B, and at point B, we know that the highest velocity will be 0 and the initial velocity will be u sine theta because the height will be of component of vertical velocity only, due to how vertical velocity only. Okay, and the s will be h, and acceleration due to gravity will be minus g. So we know that v is equal to v square is equal to u square plus 2as. So v is equal to 0 square u sine theta whole square plus 2 minus g into h. So u square sine square theta minus 2gh is equal to 0. If this will come to a left hand side, so minus u square sine square theta is equal to minus 2gh. So h is equal to u square sine square theta by 2g will be the height. Okay. So maximum height is equal to H max is equal to u square sine square theta by 2g. So at theta equal to 90 degree, at theta equal to 90 degree, sine theta will become 1. So H max is equal to u square upon tg, which is the maximum value of a height. Okay. Now come to the next one. That was your horizontal range. Horizontal range. So what is horizontal range? It is a horizontal distance covered by the projectile during the time of flight. It is the horizontal distance covered by the projectile by the projectile during the time of flight. During the time of flight. So horizontal range is denoted by R. So in for this we will take x direction motion because horizontal range is the distance. Suppose this point is A, this is point is B. So this distance AB, okay. So this is known as the horizontal range. So we will consider only from A to C. We will consider the range. Okay, again right. Horizontal range. It is the horizontal distance. It is the horizontal distance covered by the projectile. Covered by the projectile during its time of flight. During its time of flight. So consider motion in the x direction only. So in x direction, we know that ux is equal to u cos theta, acceleration is 0, horizontal distance is r, and time is equal to the time of flight. So applying the Newton's second law of motion, s is equal to ut plus half at square. So u is u cos theta, and time of flight is 2u sine theta by g plus half, and acceleration is 0 in x direction. And time is 2u sine theta by g whole square. 0 into something is 0. So that why whole term became 0. Okay. Only this term will be left, which is equal to r equal to u square 2 sine theta cos theta by g. 2 sine theta cos theta by z. Okay. So u square sine 2 theta by g is equal to the range. At 45 degree, at theta equal to 45 degree, sine 2 theta will be maximum, which is equal to 1. So r is equal to u square by g. Okay. So that was your horizontal. That was your horizontal. Sorry, horizontal range. Okay, okay. Now next topic is your velocity of projectile at any instant. Velocity of projectile at any instant. Projectile at any instant. So at any instant t, at any instant t, velocity v has two components. Velocity v has two components. Horizontal component horizontal component Vx is equal to ux plus axt. So ux we know that u cos theta and acceleration is 0. So Vx is equal to u cos theta. So they have horizontal component of u cos theta. Now come to the vertical component. Vertical component is Vy. Vy is equal to Uy plus Ayt. Uy is u sin theta minus gt. Okay. Now come to the resultant velocity. Resultant velocity is v, which is equal to under root v square x plus under root v square y. So under root of v square x means u square cos square theta plus u sin theta minus gt whole square. So on opening, you will get u square cos square theta plus u square sin square theta plus g square t square minus 2u sin theta gt. Now if you take u square common from that, so you will get sin square theta plus cos square theta. So v is equal to under root u square plus g square t square minus 2u sin theta gt will be the velocity component at any instant. U square plus g square t square minus 2u sin theta gt. Now come to the tan beta, mean angle at which it will be fired. So Vy upon Vx, which is equal to u sin theta minus gt upon u cos theta. So on putting, you will get tan theta minus gt u cos theta as an answer. Okay, so that was your vertical component. Now come to the question part from it. The previous year question which have come in your examination. First question is, what is the acceleration of the projectile at the top of its trajectory, at the top of its trajectory. So we know that the acceleration due to gravity always acts downward. So during the its whole motion, the acceleration due to gravity acts vertically downward. So The acceleration of a projectile at the top of its trajectory, at the top of its trajectory is vertically downwards. Is vertically downwards. Next is show that show that the maximum height the maximum height reached by a projectile reached by a projectile at an angle of 45 degree at an angle of 45 degree is 1/4 of its range. Okay, now come to its solution. First is range of the projectile. So what is the range of the projectile? Range of the projectile. So the range of the projectile is R, which is equal to U square sine to theta by G. Okay, and the maximum height of the projectile is defined as H is equal to U square sine square theta by G. So at theta equal to 45 degree, R will become U square sine 2 into 45 by G. So U square sine 90 by G, which is equal to U square by G. And at theta equal to 45 degree, H will become U square sine 45 whole square by G. Sine 45 means 1 upon root 2. So 1 upon root 2 whole square by 2G. 2G. Okay. So 1 upon root 2 whole square is 2. So U square upon 4G. So H will become U square upon 4G. And we know that the U square upon G is R. So H is equal to R by 4. Hence proof that our height is 1/4 of horizontal range. Now next question is so that the trajectory of an projectile thrown at certain angle of the parabola is certain angle with the horizontal is parabola. Next question is so that the trajectory of an object thrown at certain angle with the horizontal is parabola. So I have taught you this earlier. The trajectory of a parabola. So you will write the same that suppose a body is reached at a point P x y after time t, then you will find the horizontal distance is equal to x is equal to ux into t, and ux is the horizontal velocity and horizontal velocity is equal to u cos theta. From here you will get the value of time. So put that value of time in the second equation, which will you consider the horizontal sorry for vertical distance s. So y is equal to u sine theta t plus half minus gt square. So you will get u is equal to x tan theta minus gx square 2u square cos square t. So this is the equation of parabola. So you can write that this is the equation of parabola. Hence proof the trajectory of projectile is always a parabola. Now next is show that the maximum height and range maximum height and range of a projectiles are u square sine square theta by 2g and u square sine 2 theta by g respectively. So these two are also proven by me in the previous slides, the horizontal range and for the expression for um, maximum height. So for the horizontal range, we have considered the motion in the s direction, and we have taken ux is equal to u cos theta, and ax acceleration in the horizontal direction is always zero, and horizontal ranges are on putting we will get r is equal to u square sine theta by g. And for the maximum height, we have taken a direction, we have taken the motion in vertical direction because the horizontal height is only due to the its vertical component u sine theta. Okay, so we have taken v equal to 0 at highest point u is equal to u sine theta and s is equal to h and a is equal to minus g. On putting we will get h is equal to u square sine square theta by g. Now next is at which angle? At which angle horizontal range and maximum height will become equal. So we have to find at which angle the horizontal range and maximum height will be equal. So we have given that horizontal range is equal to h max. So horizontal range is equal to u square sine 2 theta by g, and h max is equal to u square sine square theta by 2g. So g term will be cancelled, u square will be cancelled. Sine 2 theta is equal to 2 sine theta cos theta, and sine square theta will be written as sine theta into sine theta. So that term will be cancelled upon 2 is there. So on cross multiplying, you will get 4 is equal to sine theta by cos theta. So sine theta upon cos theta is 10 theta. So 10 theta is equal to 4. So theta is equal to 10 inverse of 4. So at angle 10 inverse of 4, the horizontal range and the maximum height will be equal. Okay. Now consider one more thing. We know that range is equal to u square sine 2 theta by g. So for complementary angle, that means at theta and at 90 minus theta, range will be equal. Why range will be equal? Because at sine 90 minus theta, sine 2 into 90 minus theta is equal to sine 180 minus 2 theta, and sine 180 minus theta is sine theta. So sine 2 theta. Okay. So add for complementary angle means an angle whose sum is 90 degree. For complementary angle, complementary angle angles complementary angles means whose sum is equal to 90 degree, range will be same. Range will be same. Okay. So this was your projectile motion. Now come to the next topic, which is your friction. So what is friction? It is a motion which opposes the relative motion between the object. Suppose that was a body. Sorry, this was a surface, and that was a body on its surface. If we push body forward with a force F, then a relative motion come between the surface and the body, which is known as the force of friction, which is denoted by small f. Okay. So what is the definition of friction? When one body slides over the surface of another, there is an opposing force. There is an opposing force acting opposite to the direction of opposite to the direction of motion. The opposing force is called friction. The opposing force is called friction. It's called friction. Or friction is defined as the force. Friction friction is defined as the force defined as the force which opposes the relative motion between two surfaces in contact. Two surfaces in contact. Okay, that was your friction. Now come to the types of friction. So friction has generally two types. Friction has generally of two types. First one is your static friction. Second is your kinetic friction. First one is static friction. Second one is your kinetic friction. Static friction is also of two types. First is static friction. Next one is your limiting friction. Limiting friction. And kinetic friction, which is in the motion, so it is also of two types. First is sliding friction, and second one is your rolling friction. Rolling friction. Okay. So friction are of two types. First one is your static friction, and second one is your kinetic friction. In a static friction, you have also two types. One first is static friction, second one is limiting friction, and in kinetic friction, the two type of friction are sliding friction and the rolling friction. So come to the types. First one is your static friction. Static friction. The static friction, which is denoted by Fs. So what is a static friction? The force of friction. The force of friction between two surfaces so long as there is no relative motion, as there is no relative motion between them. Its magnitude, its magnitude is equal to external force. So static friction is the friction which come between two surfaces when there is a no relative motion, and when they tends to a relative motion, so that friction is known as your limiting friction, or you can say the maximum value of the static friction is known as the limiting friction. Now the second topic is your limiting friction. Limiting friction. It is Fs max. So what is the limiting friction? The maximum value of static friction, the maximum value of static friction Fs max, which comes into play, which comes into play when the body just start moving on the surface of another body. It's called limiting friction. Okay. So remember one thing, limiting friction is always greater than the static friction, and limiting friction is always greater than the kinetic friction too. Because if you see the graph, that was your static friction, that was became its maximum value. And next is your kinetic friction. It was static friction. This is maximum limiting value, and this was is kinetic friction. This the value of limiting friction. That was your friction and the applied force, right? Force. So if you see here, so the limiting friction will be a maximum friction. Okay. Static friction is always less than limiting friction, and kinetic friction too is always also less than our limiting friction. Okay. Now next one is your types of kinetic friction. Now firstly, the laws of limiting friction will be there. So come towards the laws of limiting friction. Laws of limiting friction. Laws of limiting friction. So what are the laws of limiting friction? First law is it depends on the nature of two surfaces in contact. It depends on the nature of two surfaces in contact. Of two surfaces in contact. Okay. Now second law is that limiting friction is always depend on the two surfaces in contact. Means when the two surfaces are in contact, so between them, limiting friction will act. So it acts tangent to the two surfaces. It acts always tangent to the two surfaces in contact and in direction opposite to the motion of body. Opposite to the motion of body. Okay. Third one is that the value of limiting friction is independent of area of surface in contact. The value of limiting friction is independent of area of surface in contact. Area of surface in contact. In contact. And the last one is that limiting friction, limiting friction is directly proportional to normal reaction. Is directly proportional to normal reaction. Proportional to normal reaction R. To normal reaction R. Okay. So that's all for today. In the next class, I will discuss this law one by one. And next topic is our kinetic friction. Then we saw angle of repose, angle of friction, and we will discuss some important questions